there is a converging lens which is placed over here, and the ray of light which is passing through that lens is said to be converging. When the incident light is a white light, what happens to the light rays? It just splits up into 7 constituent colors. That is the Vibgyor. Angle Q is R1 plus angle R is R2, which is equal to 180 degree. Angle N plus R1 plus R2 is equal to 180 degree. Hello everyone, I'm Vrinda, Faculty of Physics from Vidhyaashram Pre-University College, Mysuru, welcoming you all to session 6 of chapter 9, and chapter name is Ray Optics and Optical Instruments. So in today's class, we are dealing with a concept called as power of lens, as well as a derivation for the combination of lens, prism, that is refraction at prism, as well as its angle of minimum deviation. So these are the concepts what we deal with today. So first of all, we are having a power of lens. So what is the power of lens? So we know a lens is a spherical surface which is bounded by 2 sides also, correct? So power, how do you exactly check the power of the lens? The power of the lens is defined as tangent of angle by which it converges or diverges. Okay, either the ray of light converges or diverges to which an angle is drawn such that a ray of light which is parallel to the principal axis is incident at a unit distance from the principal axis. So here we have got a convex lens, what we consider, and there is a principal axis which is passing on to it. So any ray of light which is parallel to the principal axis, from the optic center, the ray of light, it converges. So here it is called as a converging type. So here I can just draw F over here, correct? So now there is a converging lens which is placed over here, and the ray of light which is passing through that lens is said to be converging. When that is the case, here the ray of light is just drawn over here, that is imaginary incident light after passing through the lens. That means there is certain deviation for its convergence, and that is given as theta, which is nothing but the power of the lens. So what is power of the lens? The power of the lens is defined as the tangent of an angle by which it converges, or in case of concave it diverges, a ray of light which is parallel to the principal axis, which is incident at a unit distance from the optic center. So here this distance is said to be 1. This is said to be the unit distance. So what do you call this as? It is a height, call it as h. And you have the distance from the optic center to f, that is the focal length. So now we have to consider a tan function. So tan theta is nothing but, it is making an angle theta. Tan theta is nothing but what do you give? You give opposite by hypotenuse. So it is h divided by f. So we have h divided by f. So what is this? Suppose if in case it is very much closer, then tan theta becomes approximately equal to theta. So I can just tell tan theta becoming approximately equal to theta. So we have theta is equal to h divided by f. If suppose h is considered to be a unit distance, that means 1, and theta is known as the power of lens which is given by p, it becomes p is equal to 1 by f is the power of lens formula, and the SI unit of power of lens is called as dioptre. Okay, so it is DIOPTRE. This is the SI unit of the power of lens. So this is all about the power of lens. Next we are dealing with some image formation for us to understand the concept. Okay, so here it is image formation in case of thin lens. So what is meant by a thin lens? Thin lens is the lens whose thickness is negligible. So it has got negligible thickness. Negligible thickness. So we have convex lens which produces a real image. So what is that we have to do if the convex lens has to produce a real image? So there is an object which is placed beyond the focal length. So this is the principal axis. This is the optic center O. So there is a point, call it as F. This is also F, and this is 2F, and this is also 2F. Somewhere between 2F and F your object is placed, that is beyond F. At that time the ray is incident in this way and it converges at the focal point, and then the other ray which is passing through the optic center passes undeviated. So just extend this. So you have got a real image which is enlarged and it is formed over here. Clear? So this is how the convex lens produces the real image. This is about the real image. Exactly the ray of light which meets at the other side. Okay. And sometimes it appears to meet. That appearance is there. No, that is just appearing. That means it is a virtual whatever it forms. Okay. So now convex lens producing virtual image, if we just check it out, this is a convex lens and you draw a principal axis and this is the optic center. Suppose the object lies, this is 2F, this is F, this is F, and this is 2F. Between the optic center as well as the principal focus, the ray of light which passes through the principal focus and the other ray passes straight from the optic center. So there is no deviation when it passes from the optic center. So it is like it forms somewhere at infinity. It keeps on going. There is no formation over here because both are parallel to each other. So what is your duty? Just to extend these lines and see where exactly it meets. So now it is formed beyond F. Clear? So that is all about the virtual image. The image which is formed over here is called as virtual image. Next, coming to concave lens which produces the virtual image. So we have a concave lens which is thicker at the edges than at the middle. Okay, there is a principal axis which passes through the concave lens. So this point is called as the optic center O. So now the object is placed somewhere over here. Okay, and the ray of light is incident till the optic center. From there it diverges. So the divergence on extension you get somewhere around the focal, that is the principal focus. Okay, so other line which is incident from the object, it falls on the optic center and without deviation it passes. So the intersection is this part. So this is the image what is formed. So this will be the virtual image which is formed at the place of the object itself. So that is all about the formation of the image, real image, virtual image, and virtual image in case of convex as well as concave lens. Next we are dealing with thin lens formula, and thin lens just a formula what we are dealing with, not the derivation. Okay, so what is thin lens? So thin lens is the one whose thickness is negligible when we compare it to the radius of curvature of the surface. So completely it is very thin and the thickness is very negligible. So what is the formula a thin lens is having? It is 1 by F is equal to 1 by V minus 1 by U. So this is the formula for thin lens, which is very important in case of the derivation, that is the next upcoming derivations. It is very useful. So what is thin lens? It is nothing but the thickness is negligible when compared to that of the radii of curvature of the spherical surface, as well as its thin lens formula can be 1 by F is equal to 1 by V minus 1 by U, where F is the focal length, V is the image distance and U is the object distance. So that's all about the thin lens. So here we are considering the combination of lens. Which lens? It is a convex lens. So the two convex lenses are combined together, that means attached together. That means here you have, let me draw the diagram over here. So you have a lens over here. Again the other lens comes in contact. So this is the combination of lens. So there is a principal axis which passes and this is the optic center. So there is an object from which the incident light is incident on the surface. Then there is a normal, so it gets deviated. After deviation, again there is one normal and again it gets deviated. So the normal which is drawn, that is from the actual ray. Here there is a I1 which is formed and the actual image is called as I, and this distance from the center of this combination, this distance is called as object distance, which comes up till here, and this distance is called as image distance, which comes up till here, and the one which stays up till here is called as V1, virtual image distance. Okay, so that is all about your setup. So this is called as L1 and this is called as L2. Both are having the optic center over here. That's all about this diagram. So having the same diagram, you will have to give the description for this as well. Now consider only one surface. This is same as that of the how you have derived the lens maker formula. By splitting up of the two lenses, you have given the lens maker formula. Similarly, by splitting up of the two lens of this combination, that is combination of lens, you're giving the formula for this. So here we have for L1, that is for the first lens, you have a lens over here and the principal axis. So from O, so this is L1, it passes in this manner. So there is a normal which is drawn, okay, and there is a ray of light which is incident over here. The ray of light which is incident over here, call this as I1, which is incident for now. Okay, so the image distance, the object distance will be U and the image distance is V1. Object distance for this is U and image distance for this is called as V1. Then according to thin lens formula, what is thin lens formula? It is 1 by F is equal to 1 by V minus 1 by U. 1 by V minus 1 by U. So for this, we will have to substitute as if this is a general formula. Okay. So for this, we have to substitute it as 1 by F1 because we have two focal lengths, F1 and F2. Okay. Because we are considering two thin lens. So 1 by F1 is equal to 1 by, what is the image distance? It is V1. What is the object distance? It is U. So this equation is called as equation 1. Now on dividing the slide, we have other set of equation for the second lens. So we have for L2, we have a diagram like this. So the ray of light, whichever it passes, it gets deviated from here. Okay, so this is called as I, and the deviation which passes over here, call it as I1 for now. So whichever was acting as an image before, that will act as an object now for this lens. It is same as that of the lens maker's formulas consideration, how I have done in the previous session. So I want you people to get back to the previous session and check on the lens maker's formula as well, which is very important for 5 marks. Clear with that? Okay, next we are having the object distance is given as V1, whichever was the image distance previously is the object distance now, and the image distance, call it as actual image distance, it is V. So then the expression becomes 1 by f2, because the second lens is having a focal length of f2, which is equal to 1 by, what is image? We have v, and minus 1 by v1. So this is our second set of equation what we have, call it as equation 2. Having equation 1 and 2, it is our duty to divide it. So what happens having 1 and 2? 1 by f1 plus 1 by f2 is equal to 1 by v1 minus 1 by u plus 1 by v minus 1 by v1. Minus 1 by v1 and plus 1 by v1 cancels out. So what remains is 1 by f1 plus 1 by f2 is equal to 1 by v minus 1 by u. This we are talking about the combination of the lens. If we consider the equivalent of the combination of the lens, how we used to consider for series, capacitors in series, capacitors in parallel, as well as series, resistors in series and resistors in parallel, all these conditions we were considering. Finally, we were giving equivalent resistance and equivalent capacitance, correct? The similar manner, there are two sets of lens which is connected together, correct? So now, if we consider the same set of two lens which is joined together completely, that means we are considering only a single lens, then it has got an equivalent focal length of just f, okay? So it can be written as the equivalent lens. For equivalent lens, what is the thing you're having? It is f1 is equal to f2, which is both equal to f. 1 by f is equal to 1 by v minus 1 by u. So this set of equation call it as 3 and this set of equation call it as 4. So we have equation 3 and 4 which can be equated as, instead of 1 by v minus 1 by u and 1 by v minus 1 by u, you can equate both, write it as 1 by f is equal to 1 by f1 plus 1 by f2. So it can be rewritten as 1 by f is equal to 1 by f1 plus 1 by f2. So this is how actually we write. And we know that according to the power of the lens, we have 1 by f. Okay, so we have two lens. So it is P1 is equal to 1 by f1 and P2 is equal to 1 by f2. So this can be overall written as, in case of powers or in terms of power, P is equal to P1 plus P2. Okay, so this is how you give the power or the focal length concept for combination of thin lens which is in contact with each other. Okay, so now we are having the next derivation which we have to deal with, and that is nothing but refraction through prism. Okay, so now before going to the derivation, let us just see what is the refraction through prism and what is meant by a prism. This is a new concept. What is meant by a prism? Have you all seen the ray of light is incident on a prism? When the incident light is a white light, what happens to the light rays? It just splits up into 7 constituent colors. That is a Vibgyor. You have already studied about this in your previous classes, that is in your 10th as well as 1st PUC. Okay. This is all about your prism concept. By having prism, you can split the colors into different constituents. Okay. So now you have got prism means it is 3 rectangular faces. Okay, so it has got 3 rectangular faces and 2 triangular faces. So one side is 1 rectangular. Okay, call this as 1. The other side it is 1 rectangular. Call this as 2. Then you just draw other side, it is a rectangular. So call this as 3. So you have just the outline as 1 and 2 and finally it is the base, call it as 3. Now we are left out with just 2 triangles to cover the prism. So this is one set of triangle which covers, okay, and this is the other set of triangle which covers. So there are 2 triangles. It is same like there are 2 triangles. There are 2 triangles for which you are joining the rectangular surfaces. One surface, two surfaces, base, one surface. So there are three rectangulars and one is this triangle, one is behind triangle, which is called as two triangle. That is, this is one set, two sets of triangle. So you have three rectangular surface and two triangular surface, which gives you a prism. So what is the refractive phase? Where exactly is the refractive phase? These sides, that is 1, 2 faces are there. No, they are the refracting surfaces of the prism. So having this concept, we have to deal with the refractive index in terms of angle of prism and angle of minimum deviation. We have to check in terms of angle of prism and angle of minimum deviation. For that, we have to have a diagram, and the diagram turns out to be a triangle . This is a triangle, which means to say it is a prism for us. One dimension image of a prism. Now, the base is fixed like this. This is a base. The prism is named as A, B, C. There is a ray which is incident on the surface AB. Okay, this is the description. There is a ray which is incident on the surface AB. So this is a incident ray. So draw a normal to it such that the incident ray, when it gets refracted, it falls into towards the normal in case of the denser medium. Now, again I want you to draw a normal to the refracted ray inside the prism, that is inside the denser medium, which is now considered to be an incident ray back again, and now it is said to be refracting towards the rarer medium. So when it refracts to a rarer medium, it moves or bends away from the normal. This is how the splitting of the white light also takes place on different wavelengths, red, blue, yellow, all those with your, okay. So now I'm just taking one set of ray which is getting deviated. So the incident ray is getting deviated. So call this as incident ray as P and Q, incident on AB. Q and R is the one which is moving incident light, and R and S is one which is getting refracted. So you have this as your incident ray, this as your refracted ray. That is, normal and the incident ray gives you the angle of incidence. Normal and the refracted ray gives you the angle of refraction. Clear with that? Now we have to extend these two lines. Call it as N over here. Okay, and this is M. We have a normal drawn M and N, and just extend this. You have got O over here. Okay, and on extending the actual incident ray over here and the refracted ray over here, we can give the angle of deviation. It is the angle of deviation. What is our duty now? It is to check the angle of the prism and the angle of minimum deviation. Angle of the prism, call it as A. This is the one what we have to check, and angle of minimum deviation. So these two are the ones what we have to identify. This is our duty now. Now we have, suppose if this is an angle of incidence, this will be the refracted ray over here, call this as R1, and the other refracted ray which is present over here, call this as R2. Okay, which can be called as I2 as well, and this can be called as I1. Got it? So this is the concept or the set whatever we are having right now with us. Now it's our duty is to check if suppose this is the point of intersection can be written as T, and the point of the line which is passing over here can be called as Z. Now consider triangle TQR. Triangle T. This is the first step what we are doing. TQR triangle. So the triangle is said to be the dotted lines which is present over there, and this is one single line. So these are the dotted lines which I am drawing. Triangle TQR. Q and R. Okay, and here we have got, since the complete angle is angle of incident, because this angle is equal to this angle, the complete set I can take it as angle of incidence. Similarly, here also the complete set I can take angle of incident. But I need only this angle. So this angle can be written as, from I, you're minusing, that is from I1, you're subtracting R1. So I1 minus R1 will be the angle over here. And here you're subtracting I2 minus R2, the angle here. So we have, by triangle TQR, we have the angle as these two angles. This angle is said to be I1 minus R, and this angle is said to be I2 minus R. So this is R1 and this is R2. So now, how are we supposed to equate it? As we know, the exterior angle is the sum of two interior angles we have already studied in the previous derivations. So according to that, it is the exterior angle for this. The extension of this is angle D. So D is the angle of minimum deviation. So D is equal to, we have got the exterior angle is the sum of two interior angles, opposite interior angles. So both are opposite to each other. So I can write in this manner. So this turns out to be I1 minus R1 plus I2 minus, plus into minus is minus R2. So how are you giving this? I1 plus I2 minus, you can take it common, and R1 plus R2. So this is D, and call this equation as 1. Now you will have to take the other set of triangle and one quadrilateral which is remaining. You're done with TQR. Now it's your duty to deal with QNR. Okay, so you're taking angle, second one, considering triangle QNR. So your Q is this. There is a dotted line which passes. This is N, Q and R. This is the diagram what you're having. So here, you know what is this angle? It is R1. You know what is this angle? It is R2. So you don't know this angle. By angle sum property, you can easily deal with this. That is, this is a semicircle. So all three sides, when you add up, you will get 180 degree. Correct? So it is like angle Q plus angle N plus angle R is equal to 180 degree. So angle Q and R is what? You can just take angle N plus angle Q is R1 plus angle R is R2, which is equal to 180 degree. Angle N plus R1 plus R2 is equal to 180 degree is the one what you're having right now. So this is according to the angle sum property. So this can be called as equation 2. You can just mention if required the angle. Clear? Later onwards the angle we will take and make it as simple as it is. Okay. So next it is the third point. You're considering this triangle is over and this triangle is over. Finally we are dealing with the quadrilateral, that is A to Q and Q to N and N to R and then A to R. So this is a set of quadrilateral. So by quadrilateral AQNR, we have again using angle sum property. This is a triangle. Okay, so this is a quadrilateral. So we are using A, Q, N and R. Having this, it is nothing but the complete quadrilateral, all four sides, it makes an angle of 360 by angle sum property. Okay, so now you are having angle Q plus angle A plus angle N plus angle R is equal to 360 degree. So we have to identify what is A. We have to identify A as well as the angle N. A and N, but these Q and R makes right angle to each other, and that right angle is due to the normal which is drawn to it. Normal drawn to the surface and normal drawn to the surface, that means it is perpendicular. When it comes to be the perpendicular, it is said to be 90 degree. So Q makes an angle 90 degree with the surface and R makes an angle 90 degree with the surface. So it is Q is 90 and R is 90. We don't know A and N. So rearrange angle A plus angle N plus angle 90 degree plus angle 90 degree is equal to 360 degree. Okay, angle A plus angle N, angle 90 plus angle 90 is 180 degree. So 360 minus 180, it is again 180 degree. Call this as equation 3. So we have equation 1, equation 2 and equation 3. So now we have got our equation 2 and 3. So now it's our duty to equate 2 as well as equate 3. So we can write it as angle N is plus angle R1 plus angle R2 is equal to 180 degree. Similarly, we have angle A plus angle N is equal to 180 degree. Equate both. So you have angle N plus angle R1 plus angle R2 is equal to angle A plus angle N. N cancels with N. So we have A is equal to R1 plus R2 in simple. Okay. Call this as equation 4. Now substitute equation 4 in equation 1 and we have equation 1 as D is equal to I1 plus I2 minus R1 plus R2. It can be written as D is equal to I1 plus I2 minus R1 plus R2 can be written as minus A. So this can give the angle of minimum deviation. Call this as equation 5. And we have, there is a diagram, that is a graphical representation. This gives the deviation. Okay, and the below one, that is the x-axis. Y-axis gives the deviation, x-axis gives the angle of incidence. As the angle of incidence increases from 0, the deviation starts decreasing until a minimum value and then it starts increasing. So this is the graphical representation of the angle of deviation with respect to angle of incidence. Okay, so this is one set of the graphical representation what we have. So this equation can be told as the angle of deviation equation. Now we have to check what is our duty according to this refractive index in terms of angle of prism and the angle of minimum deviation. Okay, angle of prism as well as angle of minimum deviation we have to check with respect to the refractive index. At the minimum deviation, the thing is like, now we are checking on to the minimum deviation. At the minimum deviation, your angles, that is the incident angle, both the incident angle will be equal to I. That means both the incident angles will be equal to I and both the refractive rays will be equal. That is angle of refraction also will be equal to R. So you can just give it as I1 is equal to I2 is equal to I and R1 is equal to R2 is equal to R. This is a set how exactly it has to come. And now on substituting for the above equation, that is equation 5 as well as equation 4, how does it go? On substituting for equation 5 as well as equation 4, we have first substitute for equation 4. A is equal to R1 is R and R2 is also R because of this condition. So it is R plus R gives you 2R. And then we have by the fifth equation, that is D is equal to I1 plus I2 gives you I plus I, it is called as 2I minus A. So the above equation can be simplified to, it is This equation can be written as R is equal to A by 2. Call this as equation 6. And this equation can be written as I is equal to D plus A divided by 2. Call this as equation 7. So now you know that according to Snell's law, sin I by sin R is equal to N, the refractive index, which can be rewritten as N is equal to sin I is what? It is A plus D divided by 2 by again sin A by 2. So this gives the refractive index in terms of angle of prism and angle of minimum deviation. We have angle of prism, call it as A. That is, this part is angle of prism and D means angle of minimum deviation. So this is the refractive index in terms of angle of prism and angle of minimum deviation. Okay, so now it's your duty. Suppose in case of a thin prism, the angle of deviation is very much smaller. So then you will be having your equation as N approximately equal to, it is A plus D divided by A. And when you equate it, you have got your, this D can be rewritten as deviation, angle of minimum deviation can be represented in capital letter D. So I can write this as N goes towards A goes towards N, and it can be written as N into A is equal to A plus capital letter D. So NA minus A is equal to D. So A is the common term, so it becomes N minus 1 is equal to A is equal to D. So this will be the final equation. Okay, so this is the place where exactly you get the refractive index in terms of your angle of prism as well as angle of minimum deviation. This is one of the most important derivation. Okay, so here it is very big, but it is very easy concept if you understand. First you will have to consider TQR triangle, then you have to consider QNR triangle, then it is said to be the quadrilateral. Having these four sets, 2 triangles and 1 quadrilateral according to the properties of the triangles, if you just mark it over, then it is very easy, then it is completely simplification till the last, and finally you can consider the Snell's law for which you will be substituting, and finally you will get the answer of the refractive index in terms of angle of prism as well as angle of minimum deviation. So in today's class we have dealt with the power of lens as well as the image formation in case of lens forming of the real image as well as the virtual image, and then the refraction through the prism as well as the refractive index in terms of angle of minimum deviation as well as the angle of the prism. We have given a formula, that is a derivation of it. Along with that, we have studied what is meant by thin lens with the formula. We have studied only the formula of the thin lens. So in today's class, this session of yours is very much important. So I request all of you to go through this very well, solve it for yourself, and then you will understand how exactly the derivation is going on step by step. Let us all meet in our next class with the next upcoming session of the same chapter with the session 7. Until then, have a good day. Thank you.